Okay, we're going to go ahead and make the images together that are in on page 47 in the methods and meanings box for formal definitions of rigid transformations. And I'm just taking a look at that image. You should be open to page 47. I'm going to turn the axes off. It doesn't look like I need it. And I'm just going to start building this stuff here. So in the first image, I see a line and a perpendicular line. And I'm going to use the polygon tool to copy this first. Quadrilateral. So remember, when you hover over the tool, it tells you how to use it. And I think this is really looks a little more like that. So I have the basic setup. Now I'm noticing some cool things. We've got an arrow at one end of line L. So I'm going to replace, oh, I didn't do that right. I'm going to replace with a vector. So that my line gets that arrow. And I'm going to replace with a vector going the other direction. And I'm going to change the label. It's an L, but it's a, maybe I have to do a caption. Why is my caption invalid? I'm hoping I can find that cursive letter L. So sometimes lines are named with lowercase cursive letters, and it doesn't look like I'm going to be able to do that. So, but I probably can do it with a text box. Maybe. So let's see. No, it doesn't look like it. So, oh, well, that's not bad. Not bad. So I'm going to turn off H. And I'm going to move L down here to name the line. I'm going to turn some things off so that only my vectors show. I don't need G. I don't need B. I don't need that guy. I don't need label U. And we're going to change this guy's name to P to match the drawing. I don't need any of these points, but I'm a little afraid it's going to turn off my image. No, that worked. Oops, P belongs there. F gets turned off. And I don't need that. Now, it's a dotted line in the textbook, so let's see if we have a way to do that. We sure do. So I'm going to change it to that, and I'm going to change the thickness of the line a little bit and take a look at it. That's okay. We can measure in a clockwise fashion to get that right angle mark. So I'm going to use the angle tool. hopefully we can measure this angle. So maybe I need a point on here to measure this angle IPA. There's my right angle mark. I don't want the name and value, so I just uncheck that. That's what we'll do. Okay, that's good. And now I can turn this back off and this back off. So that's pretty close. And now this has been what? Reflected over this. So reflect about a line, that should be easy. Hopefully, didn't work. Reflect this quadrilateral over this. Over what? Over the line that I turned off. There we go. So sometimes we use these figures over here, because all I have here is the vector, which isn't really something I can reflect over. So keep in mind that all of these things are illustrated over here too, or are listed over here. Now, I'm going to undo that because I want to see how the name changes. I'm looking for that point. Now in the book, we have a label on the point called A, and the only way I can get the label is to leave the point. I want to call it A, and it's going to reflect with us, I think. Let's find out. Reflect about a line. I want to reflect this polygon, polygon 1, over this line that I have turned off. That's great. This is perfect. See, what I got for the name here is A prime. That is what a reflected label looks like. That tiny little apostrophe right there is an important part of the label for any transformation. So if I had other vertices, B, C, D, they would show up as B prime, C prime, D prime on my reflection. So those are so important that I think we should go ahead and put them on. Actually, I want to get that back to A, and it's not wanting to do that. So let's do it again. Change this to A. Let's put a point on the polygon. And I'm not sure whether they switch, so whether they're attached. So let's find out. This quadrilateral over this line, they didn't get attached. So let's try one more thing. I just have to figure out if this is C at -269. This must be F down here, because I can tell by looking at the coordinates. And if P is at -0.86, then this one's got to be maybe here. Nope, not far enough. Nope, we got that one here. Yeah. And now this guy is over here in the positive direction. Okay, so that's 1.43. I need something a little smaller than that. Okay. All right, so what I really want to illustrate on this drawing is the C prime, D prime, E prime, and F prime. So let's forget about A for a second, and let's reflect this figure over this line and rearrange the labels so you can really see. C prime is a copy of C, F prime is a copy of F, D prime is a copy of D. And from C to C prime is a perpendicular line, from D to D prime is a perpendicular line, from F to F prime is a perpendicular line, and from E to E prime is a perpendicular line. And what are each of those lines perpendicular to? That would be the line of reflection. And the distance from the line to E is the same as the distance from the line to E prime. All of these things are characteristic of reflections and define a reflection in this way. So I'm going to draw the line that exists in the image. I'm going to turn off the object, and we're going to change the way this line looks. It's so we want style, and it's this one, I think. We're going to just make it a little bit thicker, but not much. And take a look. Oh no, I don't want to point. Sometimes when you hit the back arrow, it goes back 2 steps, so you just hit the forward arrow to go back to where you want to be. Okay, and now we need some decoration tools. So I'm going to put 2 separate segments on, and I'm going to leave their label on for a minute because I want to be able to access them. Object properties, we learned today, I learned today that in GeoGebra 5.0, the decoration tool is in style, no longer its own tab. And these 2 marks indicate that the 2 segments that are marked the same way are congruent to each other. Show label can go off, show label can go off. Okay, so this image is a copy of the image from page 47 that represents the reflection. Only ours is labeled with all 4 vertex points. Oh, and I have to turn off my segments. I got a little excited there, I'm not quite done. Eyes going off, and that one's going off. I can tell that these are the 2 pieces I need because they have the same measure. So that's not so bad. That's the illustration we're looking for, okay? Maybe I can get the next one in here on a 15-minute video. Maybe I can. We're taking any triangle and we're rotating it about point O. So let's change the name to O. Turn off some labels. I don't need a label on K or on L or on segment J or segment K or segment L. So I have the picture and it looks like a 90-degree rotation. So rotate around a point, and this is kind of the point that Brennan liked. If I can rotate right around a point attached to the figure, let's try 90 degrees clockwise and see if I have a copy. Oh, that wasn't the whole figure. Triangle around O, 90 degrees clockwise. There we go. That looks like the figure, only point P didn't go with it. So let's go back. Let's turn the label on and let's rename it point P, because I'd like the P prime to show up. Rotate this around O, 90 degrees clockwise, say OK. There's my P prime. So this is great. This is labeling things really well. And I think I'd like to move this a little bit this way, this way, this way, just to match the picture a little bit better. Now, how do I figure out how to put that arrow on? I don't know, let's look around. An arc would be nice. Circular arc would be cool. I didn't look and see how to use it. Circular arc, select center and 2 points. Okay. Well, let's give it a center here. Oh, that's neat. Okay. All right, I can live with that. But it looks like my point has to be on this side. Circular arc, select center, and 2 points. That's cool. What happens if I turn this off? Okay, I didn't think this would be this easy. And I think I can sneak an arrow on here by using a vector tool that's just really, really small. Yeah, I can. And then turn the labels off. Oops, oops, oops. Gonna be easier to do from over here. I think I'm picking the wrong one. Okay, so point N can go off. Yeah, that's not bad. Okay. There's my illustration. Now this is interesting. O prime here is right on top of O. So I'm going to move O, and now O prime, they really do represent the same point, which is why O prime lands right on top of O. So the last illustration is this box tool, which is a translation of a parallelogram. So we know how to draw a line. We know how to draw a line parallel to it. So I'm thinking if we create a segment, and I'm also thinking we could bring this closer and maybe even put the, oh, I know, I need a segment, I need a line parallel to this segment. If I'm really going to make a parallelogram, and now I'm putting points at the vertices. I'm not completely convinced they stayed attached to the lines, but they did. So I have a pair of parallel lines called M and N here, and I have a line from V to W that's parallel to segment Q. So no matter how I drag this image, my box will remain a parallelogram. That's good, because this original was created with a parallelogram. So now I'm going to turn those 4 vertices into a quadrilateral, and I'm going to turn them all off. and just leave the quadrilateral on. Nope, didn't mean to do that. See how it took me back 2 steps? So I should have it, I should be on the arrow tool. Okay, so I've got a parallelogram. There has been a translation by a vector. Let's see how it works. So translate, select an object to translate, then a vector. Okay, so here's the object I want to translate. So I guess I need a vector. Translate by a vector this object from here. Kind of goes like that. That's cool. And now these are connected with vectors. Okay. So let's go from here to here. From here to here. From here to here. So it makes kind of a box. So the vector is what's giving us the arrows. Turn these labels off. Turn this object off. Be probably quicker to do over here. I want to turn off B sub 1. I want to turn off Z. So over here, rather than right-clicking on the image and then asking to turn it on or off, I'm just deselecting the radio button next to the figure. A sub 1 can go off. And D sub 1 can go off. And E sub 1 can go off. Now I'd like to make those 4, 1, 2, 3, 4 congruent, but I don't think vectors have a decoration tool. Let's see under style. I can change the line style. So I'm going to change it to the 1, 2, 3rd option. And I'm going to change this one to the 3rd option. I think I'm going to have to do something tricky to get that label on there. Oops, oops, oops. Not at all what I wanted to do. Now I think that in order to get that decoration tool on, I think I'm going to have to decorate a segment and then hopefully get the segment decorated exactly the same way as the vector. So I'm almost done here. I'm leaving the labels on because it'll be easier to go to the properties. Style. I want this decoration and I want the 1, 2, 3rd option. Let's see, did that work? Yeah, it did work. Okay. So segment C sub 1, properties, line style, 3rd option, decoration. Okay, D sub 1. Object properties, line style, third option. Oh, that's not it. I must be on the vector. Segment, object properties, style. I'm going to try E sub 1, object properties, line style I'm getting, but why am I not getting the decoration tool now? I don't know, it's here now. So E sub 1 is the last one I have to do. There they are. I don't know why it wasn't coming up before. Sometimes you just have to use the algebra, the equations over here. I'd like to turn off the label for F sub 1. How about if I just, no, I can't turn them off because they won't stay decorated. Okay, so it's the labels I've got to turn off. For F sub 1, I can turn off N sub 1, J sub 1, H sub 1, I sub 1, and C sub 1. Well, this guy seems to be off. Am I reading that label wrong? L sub 1. Turn it off. Didn't work. Because that's not L sub 1. There we go. Okay, so my segments are getting mixed up with my polygons, so I want to turn the label off for D sub 1 and my polygon off, and it's because they're both highlighted at the same time, so they're both getting the same command. There we go. K sub 1 is off. O sub 1 is off. M sub 1. So I really just have two labels left, C sub 1 and E sub 1, but you can see that with just a couple of clicks you can get very professional illustrations. And hopefully they're helping you to learn the properties of these particular transformations we're doing. The last thing you're going to do is insert the text box for each of these figures. So this one starts with translations. Formally, a translation is a function that assigns, and remember you have to break the lines, each point, for example Q, in the plane, a unique point, for example Q prime. This is said Q prime, so that all line segments connecting an original point with its image have equal length and are parallel. I'm sure I've got some typos in there. Okay, so that's it. You're creating a professional illustration. You're typing what's on the page. So you'll have 3 text boxes, one for each translation. You'll copy what's written, and let's go ahead and put the heading in also. So along the top of the page, we have formal definitions of rigid transformations. In algebra. So the typing will take a few minutes, but it's important for learning, it's important, which is important for understanding. So that's your goal. I want to edit that typo there. We learned that okay, good luck.